All right, number 1 in 5.2, definite integrals. We have a review. We want to find the intercepts and then use them to graph the equation. So this is a linear equation. It is in slope-intercept form. I'm going to go ahead and put it in slope-intercept form. So the negative 3x I'm going to put out front, and then the minus 3 at the back. Intercepts you can find by substituting 0 in for x or y. So if we want to find the x-intercept, y is 0. And then if we want to find the y-intercept, the x-coordinate is equal to 0. So we will plug a 0 for y. We add 3. And then divide by negative 3. So we get negative 1 equals x. As an ordered pair, we would have negative 1, 0, x, and then the y coordinate, because y is 0. Then over here, same thing. This time we will plug a 0 for x. 3 times 0 is 0, so we get y equals negative 3. And then as an ordered pair, we have 0, comma, negative 3. So here are our intercepts. We would come down and tell it we're going to graph a line. And then if we go to the graph, we're going to go to x is negative 1, y 0, and then negative 3, y for negative 3, x 0. So we get that line, and we can just check it. All right, number 2, it says, when does the net area of the region equal the area of the region? When does the net area of the region differ from the region? So we're talking about definite integrals, and we've seen several examples. So the net area is going to be equal to the region if it's like wholly above the x-axis. So if we just had this, then the total area would just be that area. On the other hand, if we had a part that goes above and some that goes below, let's say bound by that, then the region would be different, because you have a positive and then you'll have a negative, and you have to subtract those two, so the net area would be different. So the areas are equal when the region lies wholly above the x-axis. That is true. The net area is never equal to the area of the region. The area is always equal when there is equal area above and below. That will give you a net 0, and the area is equal when the regions are wholly below. So wholly above will give you a net area equal to the region. All right, and then part 2, when does the net area of the region differ from the area of the region? Net area never differs. Net area always differs. Net area differs when the region lies wholly above the x-axis. Net area differs when any part of the region lies below the x-axis. There we go.